Okay, we're going to continue with our one-dimensional motion worksheet. We're on 2C, number 6 through 8. For this one, we have a person accelerating uniformly from rest to a speed of 6.6 feet per second in 6.5 seconds. Find the distance the person travels during this time. So they're accelerating uniformly from rest. Okay, from rest, it doesn't give you a number, but we know from rest means we're not moving. So that's my initial, because we're starting from, and we're doing in feet. This feet per second, it doesn't matter because it's 0. To a speed, so 2a, so that's a final speed, 6.60 feet per second, and we have a time of 6.5 seconds. Find the distance the person travels. Okay, we're going to call, even though they said distance, that means they're really not looking for the vector, they're just looking for the magnitude. But even though they're looking for that, we're still going to call it delta x. Now we've got to figure out what equation we might want to use. Now we know we have acceleration, this change in velocity over time, but what do we do for distance? We really don't have an equation that we've worked with so far. But if we look here, we have VI, VF, T, and delta x. We don't have any acceleration, so it can't be any of these bottom three because they all have acceleration in them. We're looking for change in position, so it should be one of these probably. But it's not this because we just have, one velocity, an average, not instantaneous. Look, we have VF and VI and T and delta x, so we're going to use this equation here. And if we look at this equation, it says delta x equals 1/2 VF plus VI times delta t. We also had an equation that said delta x equals velocity, and this was an average velocity times time. If we take two velocities and add them together and divide by 2, we have an average. So really, with this equation, this little section right in here is just average velocity. So we're really just rewriting the same equation a different way, so we can involve instantaneous velocities. We have all the information. It's all in seconds and feet per second, so we can just plug it in. So delta x is equal to 1/2 times VF, which is 6.6 feet per second, plus 0 feet per second. We really could have just left that out. And then times a time of 6.5 seconds. Okay, so now we just need our calculator to do the hard work for us. 6.6 plus 0 is not hard. We can do that. So 1 divided by 2, or 1/2, which is the same as 0.5 times the 6.6, 606, 6.6, times the 6.5 seconds. And we get 21.45 feet. As you notice, the seconds will cancel and we'll end up in just feet. So 21.45, I'll just call it 21.5 feet. That's it for number 6. Let's take a peek at number 7. Number 7 says when Maggie applies the brakes of her car slows uniformly from 15 meters per second. So we're starting at 15 meters per second, so that's my initial velocity, to 0 meters per second, so that's my final velocity. We came to a stop in 2.5 seconds. How many meters before the stop sign? So how many meters, that's a distance or a length before she needs to, does she need to apply her brakes. So again, we're looking for change in position. Same setup we had there, same equation we're going to use. Okay, same basic thing. So we're going to use our delta x equals 1/2 VF plus VI times t. Now the VF is 0, so we can really just cross that part out and just say delta x is equal to 1/2 VI times t, which is equal to 1/2 times 15 meters per second times 2.5 seconds. And we get all that, 0.5 times 15 times 2.5, and we get 18.75 meters. Right, the seconds cancel and we end up in meters, which is what we want because we're looking for a position. It even says how many meters. Okay, so easy enough. Number 8. Car enters the freeway with a speed of 6.4 meters per second. So we're entering, our starting speed is 6.4 meters per second. Accelerates uniformly for 3.2 kilometers. So it is accelerating, but it doesn't tell me the acceleration. It just tells me a distance, right? Kilometers is a distance. So my change its position is 3.2 kilometers. We don't like kilometers. We're going to want to go to meters. In 3.5 minutes, my time is 3.5 minutes. Again, we don't like minutes. We're going to change that over to seconds. how fast is the car moving at the end? So velocity final. Same, oh, where you can see it, sorry. We got the same variables that we had before, but now we're solving for VF. So we're going to use that same equation, delta x equals 1/2 VF plus VI times T, but now we're going to solve for this equation for VF. Before we do any of that, we know we need to convert these things into meters and seconds. Kilo means 1,000, so we're just going to multiply this times 1,000 to get rid of the kilo. So we're going to have 3,200 meters, and we know minutes, there's 60 seconds in a minute, so we're going to multiply this by 60. 60 times 3 is 180, half of 60 is 30, so that's just 210 seconds there. Okay, first thing we got to do is rearrange this guy. We got to get VF by himself. So to get rid of the 1/2, I'm going to multiply by 2. So I got to multiply this side by 2. To get rid of the T, I'm going to divide by T. So I got to divide this side by T. Okay, it's getting a little crazy, so let's rewrite so we can see what we got going here. That disappeared and that disappeared, and we just have VF plus VI. We got to get rid of the VI, so we're going to subtract him. So we're going to subtract the VI from this side and get that 2 times the change in position over time minus the initial velocity equals the final velocity. And now let's put our numbers in. I'm going to run back up here so I don't have to get a new piece of paper. So my final velocity is my 2 times my change in position, which was 3,200 meters, divided by my time, which was 210 seconds, minus my initial velocity of 6.4 meters per second. You notice we're going to have meters per second and meters per second, so we can do the subtraction and we'll end up in meters per second, which is good. So let's do all this thing. 2 times 3,200 divided by 210 minus 6.4, and we end up with 24.1 meters per second. And we're good. And that's all there is to it. I will do the rest of the worksheet on another video.